Here let's draw a cross-section through the descending pathways of the spinal cord. For simplicity, we will only use one side of the spinal cord. First, draw the lateral corticospinal tract in the lateral funiculus, and then the anterior corticospinal tract along the anterior median fissure. Although the majority of corticospinal tract fibers cross within the medullary pyramids to become lateral corticospinal tract fibers, 10% of fibers remain ipsilateral to their site of origin and descend as anterior corticospinal tract fibers. The lateral corticospinal tracts are necessary for fine motor movements, but the anterior corticospinal tracts are sufficient for gross motor movements, which helps explain why after cerebral hemispherectomy, contralateral proximal motor movements are preserved from the anterior corticospinal tracts on that side of the body. Amyotrophic lateral sclerosis is an example of a disease that causes degeneration of both the corticospinal tracts and motor neurons of the anterior horn. Now label the medial aspect of the lateral corticospinal tract as carrying arm fibers and the lateral aspect as carrying leg fibers. A central expanding cervical cord lesion, such as a syringomelia, will affect the arm fibers prior to affecting the leg fibers. Next, label the hypothalamospinal tract alongside the lateral corticospinal tract in the lateral funiculus. This tract carries hypothalamic input for visceral motor activities such as sympathetic mediated eye changes, as well as bowel, bladder, and sexual functions. Injury to the hypothalamospinal tract at the cervical level results in Horner syndrome. Now label the rubrospinal tract in front of the lateral corticospinal tract, then label the medial and lateral vestibulospinal tracts medially and laterally to the anterior horn. And finally, label the medial and lateral reticulospinal tracts also medial and lateral to the anterior horn. The action of these tracts will help you remember their organization. The rubrospinal tract provides elbow flexion, and the reticulo and vestibulospinal tracts provide extension of the neck and upper and lower limbs. Normally, these tracts are inhibited by the cerebral cortex. When cortical inhibition is disrupted, activation of the rubrospinal and reticulo and vestibulospinal tracts results in elbow flexion and lower extremity extension, so-called decorticate posturing. A lesion below the midbrain cuts off cortical and rubrospinal inputs and results in extension of the neck and all four limbs, so-called decerebrate posturing. Now let's address the posterior anterior and medial lateral somatotopy of the motor nuclei in the anterior horns. Label the posterior nuclei as innervating flexor muscles and the anterior nuclei as innervating extensor muscles. Then label the medial nuclei as innervating proximal muscles and the lateral nuclei as innervating distal muscles. You may notice that the gray matter positions of these nuclei parallels the positions of their related white matter tracts. In polio syndrome and spinal muscular atrophy, the anterior horn cells degenerate, causing flaccid weakness. In Kennedy syndrome, a form of spinal muscular atrophy, the dorsal root ganglia are affected in addition to the motor neurons. This concludes our drawing of the descending tracts of the spinal cord.